Okay.
Did you start the string?
Yes. Welcome. Good evening. Hello. This is C++ London Uni. This is session 4 of module 2. So we've been talking for the last 3 weeks about how we go about writing our own types. Hence this module, custom types. Before I get started properly, I mentioned this the last couple of weeks, but Oliver there has some a rather interesting facial adornment. Allegedly it's for charity. I think it's just an excuse, but no. So if you want to, if you're happy to, go to this URL and donate some money so that he's looking like an idiot for a month. It's for a good cause, for Movember, of course. So please do go to mobro.co/OliverCPP and give generously. Feedback. You've all seen this slide, all but one of you, because we've got one new face tonight. Hello. We've got a chat room on Slack. Slack is people who don't know, like a chat application, sort of modern version of IRC. And we've got our room in there, #CPP London Uni. So if you want to join, and please do, go to that URL, put your email address in, and it will send you a link so that you can come and chat to us. One other admin thing, not really admin, but one other notice to get out of the way. And again, I've mentioned this the last couple of weeks, but for those perhaps online haven't seen it, Ollie did this very in-depth 3-part series on test-driven development and mocking and things like that. Mocking, not making fun of people, although he's pretty good at that as well. But yeah, recommended viewing. They're pretty long, but you can watch them on fast forward, and you can follow pretty well. So don't have to worry about memorising those links. If you just go to our YouTube channel, so youtube.com/CPP London Uni, and you'll find them there, along with all of the videos from all of our past classes. All right, on with the show. So last week we talked about operator overloading. Well, we actually started talking about it the week before. But I spent most of last week talking about operator overloading. And then right at the end, about 20 minutes at the end, I started talking about constructors and destructors. I promised you that we'd go over it again today. So that's what we're going to do. Oh, and by the way, well done to all of you. Again, I know Tom said it, but sorry for the short notice with the location. It's a bit of a funny week. So well done to those of you who saw the notice yesterday and have arrived. This is pretty much a full compliment, so pleased about that.
Out of interest, who found out through the email? We just kept checking the website.
I was reminded by the email, but I was at the London C++ thingy at Skills Matter last week, where I think Tom mentioned it.
Okay. All right. I just wondered how effective you got that. Well done to
Okay, so this week it's going to talk all about constructors. So we're going to start with a bit of an overview about constructors and destructors and what they do. Then we're going to, again, I mentioned it last week, but we'll go over it in a little more detail about calling constructors, and then mostly about how we write them. And we're going to talk about member initializer lists and explicit constructors. So that's what's on the menu for today. We're a little bit squeezed for time, but you all got pizza, so I'm sure that's a decent trade-off. More pizza, less Tristan. So usually for these things I leave you with some homework, but last week we had this exercise on operator overloading that we didn't really have time. A lot of people were still going. So I sort of decided that was the homework for last week. We do have the solutions online. So the URL is just there. The week 12 bit is from I've recycled this from a previous edition of the course. So, but I can have a quick look at those the exercises now if you'd like to, or if you're happy, we can just go on. Go on, go on, go on. Okay.
Did everyone get on the Wi-Fi okay? No.
So no questions about the homework because we didn't look at it. Oh well. So let's talk about resources. Again, I did talk about this last week, but I'll go over it again. But a really common pattern when we're writing programs is that we want to acquire a resource, do something with it, and then release it later. So we call a function to acquire the resource, we do something with the resource, and then we release it. Now the resource could be one of many things. It could be some memory from the operating system. It could be a file that you want to open. It could be a network connection. It could be a mutex. It could be all sorts of things that use this pattern. We acquire it, we do something with it, and we free it. It's typically used when the resource is expensive or scarce or both. Right, so we don't want to hold on to the resource for any longer than we need to. We want to release it as soon as we finish with it. So this pattern is very common. Acquire, use, release. Unfortunately, this can get quite tricky. I mean, here it's really obvious. I've just got acquire, one function, and then release. But in general, as your programs get more complicated, it's nowhere near this simple. Because rather than one line, you could have a couple of thousands of lines in between your acquire and release. And perhaps your function has multiple return paths. So then you've got to make sure that the resource gets released on every code path through your function. And what's more, you've got to make sure that it gets released once and once only. Not 0 times, not twice, once. And this gets particularly problematic when using C++ exceptions. So we haven't really talked about exceptions in the class yet. We will do. But if you've used exceptions in other languages, Java and Python, what have you, they're very similar in C++. So in principle here, if do something with through an exception, we're not in a try block or anything, so we'd leave the function immediately and release would never get called. So that's a problem, or a potential problem. So how can we make our lives easier? How can we do this better? Well, the C++ language gives us two tools to help with this pattern. We have special functions called constructors. The constructors are member functions of a class, as we've been talking about for a few weeks now. Constructors are member functions that are automatically run when we construct a new object of that class type. Struct. Struct and class, remember I use them interchangeably. And destructors are the opposite. Destructors get run when an object is destroyed. So if you remember a few weeks ago, or many weeks ago now, near the beginning of the class, I quite heavily went into talk about value semantics and object lifetimes, and how when we leave a scope, the object is destroyed. And the reason I went into it in quite a bit of detail there is not only because it might be unfamiliar for people who've come from languages with reference semantics, but also because this notion of an object automatically being destroyed when we leave the scope is key to what makes this pattern work. So if we acquire our resources in a constructor and release them in a destructor, then the destructor automatically gets run when the object is destroyed. So by using the lifetime rules of the language, we can use those rules to manage our resources. And this is an incredibly powerful programming technique. So here I've got some imaginary struct. It's a resource handle. So this could represent some memory, a file descriptor, a network connection, mutex, whatever it is. We have some handle for some resource. And now in our example function, we first create a resource handle object. So this resource handle would have a constructor that acquires the resource. So as long as this resource handle object lives, as long as res lives, we own the resource. And now, just as we did before, we do something with that resource. This is the same thing we had on the last slide. But now, we don't have to explicitly release our resource. Because as soon as we leave this block, as soon as we leave the function, by the language rules, res is going to be destroyed. Right? Res is going to be destroyed, so its destructor function is going to run. And if we release the resource in the destructor, then we can use these lifetime rules to guarantee that no matter what, our resource will be released, and the release function will only be called once. Because the language guarantees that the destructor will run when you leave the block, and there's actually no way you can stop it. There's no possible way of avoiding it. It will happen. So now, it doesn't matter if we've got 10,000 lines that use the resource. It doesn't matter if we've got multiple returns. Because any way that we leave this function, res is going to be destroyed, the resource is going to be released. We can't forget to do it, and we can't do it twice. And if our do something with function throws an exception, and we get kicked out of the function that way, well, the language rules say when we leave a function due to exception, all the local variables get destroyed, including res. We get cleanup. It gets cleaned up. Our resource is released. Right, this is monumentally brilliant. And I should have changed this because I said last week that playing a central role isn't really a strong enough term. Really, this is absolutely core to how you write C++ these days. It has a name. The name doesn't make much sense. So this pattern is, you might see the abbreviation RAII. And technically that stands for Resource Acquisition is Initialization, which doesn't really explain it very well. I prefer the term Scope-Based Resource Management, which is a bit more wordy, but actually tells you what's going on. We're using the scope, that is, these curly braces that manage the lifetime of our objects. We're using that to manage our resources. Acquire the resource in the constructor, release it in the destructor. And this is such a common pattern that the C++ library has some types that can help us. Standard vector does this. You might not have realized it because you've probably used vector quite a bit in the exercises you've done so far. But vector is actually using this pattern. When you construct the vector and you add things to it, it's gone and asked the operating system for some dynamic memory. And it's a handle, it's holding on to that memory. And then later on, when the vector gets destroyed, its destructor, the vector destructor, returns that memory to the operating system. So vector is using exactly this pattern. So you may not have realized that, but that's exactly what it's doing. There's another class called standard unique pointer that's also very commonly used for this. It's one of the what we call a smart pointer, and we'll talk a bit more, well, quite a lot more about smart pointers later in the course. So this pattern, RAI, stupid name, Scope-Based Resource Management, is brilliant, and I cannot emphasize enough how fantastic it is. And it's the reason that we can get away without having garbage collection, as they do in many other languages, most other languages, in fact. And Rust, for those who have heard of Rust, it's hip and trendy at the moment. Rust uses this RAI pattern everywhere. And it's kind of amusing for those of us who've been doing C++ for a long time, because you'll find some hipster guy writing on his blog who's just discovered Rust, like, this is the most amazing thing ever. It's like, yeah, we've been doing this for 20 years. But anyway, that's just me.
One person junk is another person's treasure.
What?
There's a saying. One person junk is another person's treasure.
Okay. Oh, yes.
Is RAI no more simply scope-based resource?
That is what it is, yes.
Simple as that.
Yes.
It's always somewhat a paradigm as well. You should design your code in that way. It's something of a paradigm that's enabled by the languages.
Yes.
Scope-based language.
Yes. And
Does it sort of connote what you should and shouldn't do within constructor? Stuff like that?
not so much. It's about using the language rules to manage your resources. So yeah, RAII is not a difficult concept, right?
It's like a $25 term for 5% rate.
Well, yeah, it's full of new phrases I've never heard before. So, all right, that's going to be exercise one. Everyone's got to come up with some sort of idiom that I've never heard before. We've had two already. Okay. So I already said this constructor, special kind of member function that is used by the compiler, or the compiler inserts a call to it when we're creating a new object. And the job of a constructor is to make our object ready for use by, for example, acquiring resources. There are other uses for constructors, but the RAI is just so cool, I wanted to tell you about it. So we write a constructor as a member function of our class, of our struct, class, struct. We write it as a member function which has the same name as its enclosing class and no return type. So if you've used Java or C#, they took the C++ syntax for that. So constructors in those languages look exactly the same. So here's a little example struct, and we can see here we've written a member function called example, which takes an integer parameter and has no return value. So just as with member functions, I'll go into this in a bit more, but just as with member functions, we can have any number of parameters we like. In this case, I've just said is one int, but we could have 0 parameters, we could have 1,000 if you really wanted to. Probably not a good idea, but in theory you could. Conversely, a destructor is used when we're destroying an object. And typically, a destructor will be used when the class owns some resources that need to be released. The way we write a destructor is very similar to a constructor, except that we put this little tilde character at the front. A class can only ever have one destructor. The destructor takes no arguments. The destructor is always written like this, has no return value. This is what a destructor looks like.
Only one destructor function and one construction function?
You can have as many constructors as you like, but only ever one destructor. And, of course, you don't have to write a destructor. So all those structs we've written so far, they didn't have a destructor. So every class, how do I put this? Every class has a destructor, every struct has a destructor, but if you don't write it, the compiler will provide one that does nothing. So by default, you'll have a constructor that does nothing, but you can, if you want, you can override the constructor by writing a member function that looks like this. Yeah?
So is that a static? Is that a static member function?
It's not a static member function, no. It's an instance function, like a normal member function.
So every instance of the example gets a constructor.
In the same way that like a normal instance member function just operates on that instance, the destructor operates on that instance to destroy it.
So it's not one class shared, not one method shared by the whole class. It's every time you do something, you have an instance of destructor. Rather than being a class function.
Yeah.
It's just an instance function. Yeah?
It's an instance function, yeah.
Member.
Interesting. Because we're not using any more new and delete, is the destructor not that useful any longer?
Oh, that's not true.
Okay.
I was never sure.
So when a class gets destroyed, things happen in a particular order, right? And that order is, first of all, your destructor, the class destructor, gets run. Right, so whatever happens in the body of this function, that happens first. Okay. After that, each of your member variables gets destroyed in the reverse order in which you wrote them. So it goes from bottom up. Okay. And in destroying each of those, it will call the destructor of each of those member functions. And after that, it will destroy your base classes in order, but we haven't got on to talking about base classes yet. Okay. This means that if one of your member variables holds a resource, it will have its destructor called as part of your destruction process. Right, so somewhere, if you're using something like unique pointer has a destructor that will call delete for you. Right, so when we say don't use new or delete, we are saying prefer using these resource handle classes that manage it for you. Because if you do that, if you use a handle, a resource handle like unique pointer, like vector, if you use that in your as a member variable, you don't have to worry about doing these things in your destructor yourself, because the fact that all your members get destroyed takes care of this for you. So yes, I think that's a good point. Is that, but actually with this notion of resource handles, we rarely actually need to write a destructor. It's good to be aware that they exist and what they look like, but we rarely actually need to write them ourselves. It's better to use these handles that the standard library provides, things like vector, things like unique pointer, things like shared pointer. Okay. Calling constructors. So our examples so far, we've used this point class over and over again, point struct. And whenever we've created that, we've written it as point and then curly braces, and then we've initialized all our members in there, right? So, has everyone got this, by the way? So we've had this recurring theme of this simple struct point to int members. So one of the ways we've initialized this is, for example, to say point p 1, 2. That's curly braces. My handwriting's not very good, sorry. Curly braces, and we put the 1 and the 2 in there to initialize x and y to 1 and 2 respectively. And what you notice is that our struct point doesn't have a constructor. It's actually a special case. This is a special kind of struct called an aggregate. This is something that's inherited from C. So if we have something very simple like this, that has only public members, as this does, and it has no constructors that we've written, we get this special functionality that we can, basically for simple structs to avoid having to write your own constructor. It's something called an aggregate. It's just a bunch of data. Right? There's nothing smart about this class. It's plain old data, as people like to refer to it. You even hear about people talk about pods. They mean plain old data. They mean just things like this, just a pair of pods. Whatever.
Pojo, if you come from Java, it's basically the same principle.
Pojo.
Plain old Java object.
Oh, okay, well, sure. So this is an aggregate. We always have to use these curly braces when we're initializing aggregates. But if our class does have a constructor, so now I'm going to write another version of point that this time does have a constructor. So now I've got struct point, and we've got what looks like a member function taking 2 ints. I really should have used a different colour. So now struct point has oh, I should probably put members in there. You can imagine that it's got the integer members in there as well. But now struct point has a constructor, so it's no longer an aggregate.
You need to make the members private. If you went to public and use curly braces, it will still just directly.
Not if it's got a user defined. So now, if we write point P in curly braces, what it'll try and do is it'll try and find a matching constructor. Now, as it happens, I've given this struct a constructor that takes 2 ints. I've supplied 2 ints there in the call, so this is going to match perfectly well, and it's going to call this constructor, and everything's happy.
So sorry, shouldn't the ints have the name?
No, well, you could do. This is just a declaration. We're allowed to omit the names from a function declaration.
Oh, okay. But isn't like a good idea to give the names?
Well, usually it would be yes. I just don't have a lot of room to work with.
Oh, okay, okay.
Besides, I like to do slightly odd things sometimes to keep all of you on your toes. So Tom fell for it. It's like I throw in auto sometimes. Yes.
What if you had a third member field, right? So it's int x, y, z.
Yes.
But
This is in for the first version.
okay, let's assume the fields were the same x, y, z in the second as well.
Yes.
And then you went ahead and you did point P for the first one. You did point P 1, 2 braces
Yes.
with aggregate initialization.
With aggregate. So okay. So this case.
Oh, so this right? No, right.
This is an aggregate. This is not an aggregate.
Oh, I see. But you can still use the same syntax.
You could, yes, that's what I was.
Right.
I need another colour pen. Is there any pens lying around? Oh, there's I've got a green one. Yeah. Oh, remember that. Okay. So this first one, this struct has only public members and no constructor. So this is an aggregate. This one has a constructor, so it's not an aggregate. So when we initialize it using these curly braces, it'll try and find a matching constructor function. And as it happens, this has a matching constructor, so it's all happy. So your question was?
Actually, now that you explained it, case number 1.
Yeah.
Say you had X, Y, Z,
Yeah.
and you passed in point P1 2 as you got there.
Yeah.
Would that be an error because you're not initializing everything?
It's not an error. What happens is that anything you don't specify gets it's called value initialized. So basically for an int that would be 0.
Right.
So in fact I could say like point Q and then just have empty braces and that would be X, Y, and Z, whatever, would all be initialized to 0. But for this case that wouldn't work. So for an aggregate that would work because it just initializes them member-wise, as we say. For this case it wouldn't work because it has to try and find a matching constructor function. So using this form, the t being the type we're initializing, so this example point, and we use the curly braces. If it's an aggregate, that's just going to initialize your members in the order. Otherwise, if it's not an aggregate, if it's got a constructor, it will try to call a matching constructor. But for types which do have constructors, so case 2 here, we can also use round brackets. So curly braces only work, today anyway, I think it's going to change in C++20, but at the moment anyway, for aggregates you can only use curly braces. For non-aggregates, you can use curly braces or round brackets. I could write point Q, and now I've used round brackets. I'm given this constructor the arguments 3 and 4. So using the round brackets sort of makes it a bit more obvious that this is a function call. Because it is a function call. It's a function call here as well. But this actually makes it obvious that, you know, it looks like you're calling a function if you just saw that bit. So, life is simple, right? For an aggregate, always use curly braces. For a non-aggregate, either use curly braces or round brackets. Life is simple. Life isn't simple, alas. It would be, and in the vast majority of cases it is, you know, just nice like that. But there are, as ever in C++, a couple of awkward corner cases that make this a bit more tricky than it should be. Because there are some types for which these two forms do slightly different things. The first one is what we call a list constructor, and the second one is not. So this only applies to types which can take a list of things for initialization. And one of those is standard vector. So if you say standard vector, v, and then curly braces, 1, 2, 3, 4, 5, that initializes a vector as containing 1, 2, 3, 4, 5. But if you say standard vector v2 with round brackets, it'll try and find one of the dozen or so vector constructors that matches. So for the overwhelming majority of types, these two forms do exactly the same thing. For a small number of them, unfortunately including the one that is very, very commonly used, they do slightly different things. So the question becomes, which one do we prefer? And that's largely a matter of style more than anything. So they both have pros and cons. So if you use this format with the curly braces everywhere, you don't really have to care whether you've got an aggregate or a non-aggregate. But you can sometimes get list initialization when you don't want it. There's another problem with this round bracket form, which is actually largely why they brought this in the first place, which is that sometimes it'll look like a function declaration, which is really unfortunate. So just to imagine that, if we had R. So now, here, if A and B are types, this is declaring a function called R that returns a point and takes two unnamed arguments of types A and B. But if A and B are variables, then this is calling the point constructor. So in most cases, the compiler has enough information to know whether you want to call a constructor or declare a function. There are some odd corner cases where it doesn't. And that can lead to some very strange error messages, but hopefully most compilers actually these days are smart enough. This thing about this ambiguity between calling a constructor and declaring a function actually has a name, because people hate it so much. They call it the most vexing parse. So parsing is the process of looking at the symbols of your code, source code, and turning it into a meaning, or trying to decide what those symbols mean. And this is called the most vexing parse. It's ambiguity between calling constructor and declaring a function. So, oh yes, as I say, some compilers these days, Clang especially, is smart enough to know, to be able to guess with reasonable accuracy, that what you actually meant was that you wanted to call a constructor, but it's required by the standard to interpret it as a function declaration. When that happens, it'll give you a warning. It'll say, I don't think this is what you meant. Try using curly braces instead. Or there are a couple of other ways around it. Anyway, having scared you thoroughly, oh, one final note on this. I tend to always use this form, and only on particular occasions use this. Other people do it the other way around. They prefer this form, and only on occasion use that. It really, like I said, it's a matter of style. But I think for most of my code that you'll see on the slides, etc., I tend to use curly braces everywhere.
It can bite you when you work types and have constructors with varying overloads. A good example is if you listed vector and you have a vector of numbers, and you actually wanted X elements, you wanted to proof fill it with X elements. Curly braces in one default, you think, I forget exactly what you end up with, but I think it's basically just 2 elements with those values rather than being 10 zeros.
Control. So this is what I was talking about with standard vector. V1 here, we're using curly braces, so this creates a vector that contains the numbers 2 and 3. This is the list form. The second one is calling a constructor that takes 2 integer parameters. So what this actually does is create a vector of 2 elements, both of which are initialized to 3. Right, so just...
I realised what I was thinking of earlier. If you, it was things you complain about in standard.
Yeah. I know what you were as well.
If you delete the default constructor, it still compiles.
Only if you do it in class. If you do it, yes.
Yeah.
That was a detail I just didn't want to go into. In C++20, yeah, there is a proposal which I think just got accepted in the last meeting, which will let you call aggregates with round braces as well, and we'll do aggregate initialization.
I thought you were going to say the designated initializers from C, but okay.
Oh, well, that as well, but
That's the nicest one. Just do, like, once we've got designated initializers, just do that. It's so more readable. Not that I'm a C fan.
there are enough complications with this, and I don't want to overload people's brains too much. But let's get on to, so this is the various ways we can call constructors, but let's think about now how we can write them. So I've said this already. Job of a constructor is to make the object ready for use. Includes acquiring resources, setting the initial values of our members, and what's called in the terminology establishing our class invariants. So a constructor is a member function, a special kind of member function, but it's a member function nonetheless. And so we can write the declaration and the definition separately. That is, we have to put the declaration in the class because it's a member function. But just as with ordinary member functions, we can write the definition in another file. And that's a very common thing to do. We can also write the declaration and the definition together, just as we saw with other member functions. You can write the definition just straight in the class, in the struct definition itself, or you can write your constructor definition in some other file. So like normal member functions, we usually do, have multiple overloaded constructors. So we talked about, last time we were here actually, we talked about function overloading, member function overloading, how we can have multiple member functions which differ in their parameter types. That applies to constructors as well. Yeah.
If you're defining it in your header, you need to kind of int it to have it x and y.
If you want to use those variables, yeah. Otherwise, if you don't give them names, you can't refer to them.
I think you meant in your structure, have to do int x semicolon in y. Is that your point?
No, it's just that.
I think they means the parameter names for the pointer constructor in the second case.
Oh, sorry. Yeah.
Okay, so here I've got a struct called myType, and this is a constructor, so it's got the same name as the class, no return type. In this case, it takes no parameters, and it's got an empty body. So we've defined this in the class, and it does nothing. Right? That's fairly useless, you might think. Does nothing. Now we've got a second constructor. So this is an overload of the first constructor. This one takes const reference to a string. And we'll see in a minute, we've got a member function, a member value, member variable called str. It gets initialized from this. Now I've declared a third constructor. So we've now got three overloads, three constructors. Constructor taking no arguments, a constructor taking a string reference, and a constructor taking an int. The first two I have defined in the class. So this is both a declaration and a definition. In this case, the definition does nothing. In this case, we assign to one of our member variables. For this constructor, the int constructor, I've only provided a declaration. And here I've said we've got one member variable named str of type string.
And your braces, sorry, str braces, right?
Yes. Yes. So what this says is that by default we just want to initialize it with an empty string. Right. We'll get on to exactly what this does. This is called the default member initializer.
Now what would happen if you wouldn't use the braces at all?
If you didn't have the braces there,
It wouldn't be initialized?
it actually would in this case because standard string is a class. we'll get on to talking about these default member initializers in a bit.
In any case, in short, you would initialize anyway.
In this case, it would, but if it was an int, for example, then it wouldn't.
Yeah.
So this is just the declaration. We have to write the definition somewhere. So typically, you put this bit in a header file, and then you put the actual definition of the constructor in an implementation file. And what does it look like? Well, it still has no return type because it's a constructor. It's no return value, no return type. And we write it just as we would write any other member function. So when we're writing the definitions of member functions, you remember we put the class name, and then colon, and then the function name. And that's exactly what we do here. In this case, the function name happens to be the same as the class name. So this is a definition of the constructor for my type that takes a single int parameter. And in here we convert the int to a string, and we assign that to our str member. So now we have our main function. And first of all, we create my type, an instance of my type, a my type object. We named it M1, and we provided no arguments. We've just used empty braces. So what does this mean? Well, first of all, is my type an aggregate or not? Is my type an aggregate? No. Why not? Because it's got a constructor. It's got multiple constructors. So my type is definitely not an aggregate. So what's this going to do? Call a constructor. Yeah, which one? We've got three options. The first one, exactly. So we haven't supplied any arguments, so it's going to look to see which of these matches. Well, there's only one that can possibly match, so it's that one. This is a bit trickier. So now I've just said my type M2 and haven't put anything there. So what's going to happen here? People who haven't written quite as much C++. I have you, and you all yelling out, and you're the three who've written the most.
I didn't say anything on this one.
Okay.
That doesn't give any argument.
It's the same, exactly. So here, this is going to do exactly the same as M1. It's going to call this thing we call the default constructor. So I'll say it again in a minute, but the constructor that takes no arguments is called the default constructor. So in this case, we can get away with not providing the empty braces. These two things do exactly the same. So that's why you were asking about this string member before. Well, string is not an aggregate. It has several constructors. So in fact, if we omitted that, it would do exactly the same thing. However, if my type was an aggregate, then this would do something potentially unsafe, which would be to leave the members uninitialized. Right? So it does the same thing in this case because we happen to be dealing with a non-aggregate, but if we had an aggregate, this would be unsafe. So to be on the safe side, so that you never forget, I recommend to always write default initialization like this and not like this. That's something I admit I sometimes slip on myself because it's just habit. But this is sometimes better and never worse. So it's a really good habit to get into, to just when you default initialize something, just use empty braces rather than leaving it without an explicit initializer.
Can I ask something about the previous one? That my type int, where there is this variable str, str. This str, what's the life of this thing?
It's a member variable, so it belongs to the my type object.
So will be still there even after closing the function?
Yeah. Even after, so we're not declaring a new variable here. We'd have to put the type in there if we did that. So this refers to our member str.
It lives on the instance. You have M1 and M2. Yeah. So str lives as long as M1 or M2 does. The M1 and M2 each have their own str.
In Python, it's say like self-dot, but in C++
you don't have to, exactly. Yeah. Yeah, absolutely.
It's this arrow.
Okay. Case number 3. So I'm really testing you out on all this initialization now. So now we've got M3 and we've got curly braces with hello world in it. So which is it going to be?
The second one.
The second one, absolutely. So this thing, hello world, we can convert it to a string. We can't convert it to an int. And obviously the one that takes no parameters is out. So this one matches, so it's going to call this constructor. Brilliant. And we've got M4. And now we've got 99 in brackets. Round brackets. This is going to call... Yeah, it's not a trick question. It's going to call this one. Yeah, it is. So this is the case that we had here. We're calling constructor. This is not an aggregate, so this is going to work. This is going to call the constructor that takes an int, because 99 is an int. If we used curly braces in there, it would do the same thing. And just finally, now we've got my type M5 and an empty pair of round brackets. So what's this going to do? Any guesses?
3 choices.
Okay, it can't call this one. It can't call that one. It should call this one, right? That's what we're trying to do. We're trying to call M5 and call a constructor that takes no arguments. Oh no. Oh no, that would be simple, right? This declares a function called M5 that takes no arguments and returns my type. This is madness, right? This is like, it's so annoying. It's ridiculous, but for stupid reasons, this is a function declaration, not a constructor call. This language drives me insane sometimes, mostly just because of this rule, this thing called the most vexing parse. This is why it's vexing, because we've got this nice pattern and this nice rule, and then we've got this stupid.
Judging by the face of them, I think some people might not understand why it's a function declaration.
Is that a legacy thing?
Yes, it's absolutely a legacy thing. But you can imagine if we just wrote this line outside of main, it would obviously be a function declaration,
Yes.
right? And due to a legacy thing from C, you're allowed to declare functions. You can't define it, but you're allowed to declare a function within another function.
So would you normally get like comments by someone saying this is a function, not constructor?
Well, normally from Clang, at least, and probably the other 2 compilers as well, will say to you, you've declared a function, but you probably didn't mean to. Right, try using curly braces instead.
Okay. Or you could change to void.
No, that would still be a function declaration.
Will still be a
But then you would know it's not constructor.
Well, imagine if I call it int not main parentheses. I'm declaring a function called not main that returns an int, because main returns an int. So if I use curly braces, I'm now declaring a variable called not main that is an int and it's initialized to 0.
Did you hear of the saying in C++? Do not do evil.
No.
So what can I say? The language is 30-something years old, 35 years old or something. There are some odd things that have crept in. This thing with the curly braces was an attempt to solve that, so you could just say, use curly braces everywhere, but then they went and screwed that up by having this initialization do slightly different things for some types, such as one of the ones that you use all the time. So initialization is a bit of a mess. But basically, use curly braces most of the time, and you'll never run into this thing. And then just in the odd occasions where you actually definitely don't want to do list initialization, so when you've got a vector basically, and you particularly want to call one of the vector constructors, then you use the round brackets.
Could be cynical about it, so that's where your day rate comes from.
Well, maybe. Yeah.
So, I don't know if you said this before, but why is with my type into declaring that one? Why is it bad if you do an aggregate?
Okay, so well, let's forget about aggregates for a minute and think about like built-in types. So if this was just int m2, that would leave it uninitialized. So it would just contain whatever random junk happened to be in the memory at that time.
Yeah.
Right. So that's really dangerous because we can't read from it. So that's technically undefined behavior and can actually be a security problem in programs, because if an attacker can arrange for some particular value to be left in the stack. But anyway, it's.
Is that only for you that uses defined types? Yeah. Because if you did int, would it not default just to 0?
No, it doesn't. That's the point. But if it's a built-in type, it's uninitialized. So. Yeah, for class types, sorry.
That's confusing because when we did in the list there, you said it would initialize it to 0. When he said he called the 3 arguments.
Yes. This is why this is a really complex topic. Because we're using braces, we get what's called value initialization. So we use braces. Anything that we didn't mention gets its default value. However, here we haven't used braces or anything, so if this were an aggregate, all of its members would be default initialized. And the default initialization state for an int or for all the built-in types is undefined, random, memory, can't read it, mistake. So for safety's sake, it's always better to use this form.
That's because the worst comes to the worst, we'll initialize it to something.
Yeah, absolutely. This guarantees that if my type could be like a type alias, could be we can have generics as well, templates as they are in C++. If my type were an alias for a built-in type, then M1 would initialize it, and M to 0 or whatever the equivalent of 0 was, and M2 would leave it uninitialized.
So for example, say you're doing, say, you need to use M1 in a loop.
Yeah.
And so you, I guess, don't want to keep reinitializing it in the loop just before you use it.
Right.
I presume. I mean, it's expensive computation to keep initializing. So you initialize it outside the loop and then just reset it inside the loop every time you want to use it.
You talk about if it's an aggregate. What kind of type? Like you talk about a type that has a constructor that runs code, a destructor that runs code.
Yeah. So just say an int outside. When you declare an int outside of a loop, if you want to use repeatedly in the loop,
That makes no difference. It's definitely not. If I have a loop, I'm declaring it in the loop versus declaring out of the loop, using it in exactly the same way.
Yeah.
But isn't that good practice though? Because if you use a massive object, it would be the same thing.
Exactly. If default construction for an object was expensive.
Yeah, I'm saying just really good practice.
Yeah. So that's the only way I can think of needing to initialize a variable. But before you use it, otherwise you could just initialize it as
If you use PowerPoint, you can have a vector of items, right? Maybe I declare outside of the loop. At the end of the loop, I just clear it and fill it with new stuff, right? Each time I go around, versus just declaring it in the loop. And obviously, it just gets destructed, reconstructed. Basically, the same. It's probably more breathable to just let it get constructed. That is our AI. That is the paradigm you should use. There are use cases where you wouldn't do it. Maybe it's too expensive. There probably wouldn't make sense to move it anyway.
It might depend on the problem you're using as well. Because some problems you need initial value to start from. You're doing stepping stones sometimes. So when you go in a loop, you need that initial value. Maybe like if you're multiplying every time, it would make sense for your variable to be 0 because your whole code is 0. If they initialize to 1, it wouldn't make sense.
There in the first part.
Okay, so very briefly, I just mentioned this on the last slide, but a constructor which can be called with no arguments is called a default constructor. And a default constructor is special in many ways. It's actually what we call one of the special member functions. And if we don't write any constructors for ourselves, the compiler will try to provide a default constructor for you. And we can explicitly say that we want the compiler-provided default constructor by writing this funny equals default thing as the definition of our default constructor. So the default compiler-provided default constructor just default constructs all of our members in turn. So remember, default construction for a built-in type is undefined. Default construction for a class type means call the default constructor. So this is the same as we just had, except this time I've written the default constructor here as equals default. So this says, the compiler, I want you to write this for me. And what that will do is default initialize all of our members. In this case, we've only got one member. So this does...
Would you be able to use the, let's say, the default with any order?
No. So this equals default only works for what are called the special member functions. There are 6 of those. We won't go into all of them today. But the default constructor is one of them. The destructor is another one. So you could also do tilde, squiggle, my type, empty brace, empty brackets. That would signify the destructor. And then you could do equals default in there. But there's no point because every type has a destructor. So if you were to omit it, you get the default anyway. So there's really no point in explicitly defaulting your destructor. For the default constructor, we can. This is called explicitly defaulting. So this is an explicitly defaulted default constructor.
But if that's in any case, default constructor, what's the point?
What do you mean?
Because if I wouldn't add the equal default,
Yeah.
it would be still a default constructor.
If you just had curly braces there, an empty pair of curly braces. Yes, except there are certain differences because it wouldn't then be considered what's called a trivial constructor, and that can be quite important in some cases.
So, for example, what constructors will the default constructor provide you in that example?
So here, this will just do exactly what it did in the last.
Just an empty one.
Yes. So it'll default construct all of your members. So in this case, well, actually, in this case, it will call the member the designated initializer, the class member initializer here. So we've said, I want standard string to be initialized with an empty string. So that's what equals default will do.
Yes, if you put a value in string,
It would default to that, yes. But we'll talk a little bit more about these towards the end of the session.
Also, you can default it outside of the types definition as well. You simply declare it there and mark it as defaulted in the translation you need to. I've had a specific case ages ago that I've forgotten the reason for. We were working between 2 compilers how to do that. Don't default it in there.
Okay. Right, this, unfortunately, URL hasn't come out very well because GitHub assigned me a random one. But we do have a little exercise to complete. Involves writing constructors. Sorry?
Based on Slack.
Oh yes, this
Oh,
is
based on YouTube.
for those. This is a capital O, by the way. I'm pretty sure. I will just copy and paste that onto the Slack channel for those who are logged in.
Those who are watching, it is on the YouTube video now.
So assuming you're logged into GitHub, because you've all got GitHub accounts, right? Assuming you're logged into GitHub, you'll be able to go to that URL, clone it into your own copy.
Yeah, you click the button and it creates a clone for you.
It creates a clone for you. Yeah, absolutely.
And then you just download, do a clone
I
from
think it's
GitHub to
Ollie, I think you have a mistake because it's 0.
Oh, it's a 0, not an O. Oh.
I think so.
Right, I just click the link and the link works correctly. So yeah, no, it is a capital O.
It's
Just
GitHub should be smarter and should not
Yeah.
give you URLs with links with ambiguous characters in. Should it?
Go to Slack or our YouTube and just click the link there. I recommend. Saves you trying to, but it is no, it's a capital O.
No, no. I promise I didn't just put the exercise in so I could stop all the beats.
No, I moved the cleaners and doing the room. But help yourself.
So yeah, as usual, if you have any problems, raise your hand and me or Ollie or Justin will
I'll be happy to help.
just wait till I finish my piece.
There's a whole bit around here.
Especially all that bit with the initialization.
Sorry. Which second? Who's this bastard right here?
He looks. That was 2 years ago. No, 3 years ago.
I mean, he's let his hair grow out, yeah. Still has a tattoo. Probably, like, I saw I have a tattoo already.
You've probably done this before, John.
Probably. There's no harm.
Well, no.
I think I did actually.
I'll be sure to let him know that. Yeah.
He's way younger than you.
No, I'm going to show it to him. He's lost it. He was trying to find.
And obviously help yourselves to any refreshments.
Yeah, help yourself. If anything's run out, let me know. I can restock it. What's happened?
I've never heard of that.
Yeah, contact their support because obviously it's insane if you're a real person. So you're speaking for a bot.
You can't know. You can't use that classroom.
I mean, is it if you can create it? But I would contact the support. That's nice.
Yeah, that's reasonable.
But it says that you've been marked as spam. Yes. You are marked as spam. It's been free with someone else.
I think it would be nice to sort of word end and no. I'm saying.
It's not. No, I see what you're saying. It's highlighted.
Highlights it as a keyword.
Yeah, it's not a keyword. It's not a keyword. Obviously, some languages do have it as a keyword. It's a C line, right?
Yeah.
A C line.
I don't know, I've noticed it as well. Very silly.
They copied it from Ruby.
I opened a beer and put it down somewhere.
What did you open? Brownie. Is that? Email support at github.com or use the contact form.
Yeah, I'm
So they should be, if you go to
That's
that,
pretty compiled header.
you should have got some code to check out.
Yeah, kind of. There's the file stuff. Right.
So now you should be able to go to open folder, Visual Studio. Should be able to. And that's the They won't have a solution. So that's
Yeah, that's probably it. No, I built it. Just put it in the panel. For God's sake, I'm just not bothered.
So now if we try opening that folder.
Say that until they actually do it. Because the one thing they need to do is they can gut the hard drive and then NVMe and just stick it in the computer server. Well, if they think of this, what if they estimate what it will cost them to give you a credit in the book, yeah, we should
So it's a ship. Yeah, okay. This one's something.
call it minus because it's different.
No, wait a second, we cannot do this because the start is a point.
Yes.
You can just do start. That's not wrong. Just do start.
So if anyone's wondering, the authorized GitHub bit is silly because you're authorizing GitHub to access your GitHub. GitHub pass-through is invented by GitHub, but they use their own authentication API to use that authorization.
Start is. Can you look at the class when it starts?
I wanted to of
Start is point. So you can try to find. So if you use Initializer instead, class starts at that point already. Class starts at that point already.
sorry, I don't
Anything is. I would still use code.
when it comes to default. So then we do like,
That's correct.
Oh, so yes.
Yeah, because we're a bit pushed for time today with a slightly later start, don't worry about the last bit with the length. That was meant as a little, for people who found the constructor stuff very easy, just to get you to do a little bit of maths, but it's not really essential to learning about constructors, so don't worry about that.
Unless it's all trivial to you, then feel free.
Yeah. Of course, anybody who does do it before I call time gets a free slice of pizza.
Now, sorry, Barbara. I just clued him in on. I clued him in on.
I think you've done something very impressive. One of the exercises, that's it. A student
Ah, you want to sit there?
I was quite impressed. So yeah, we should show it.
Well, he said it's great.
Because then I have the you will find it from so that there are the nicknames, there are all the just like
Still have case-sensitive substrings there.
Just says running.
but it's not it's fun. Let's say that you want to find those students somewhere in there because
Try listing the student, which is your pagination.
these are marks and you also are the substance. So
You need to test the constructor and see
yes,
ASCII
so
zero zero. That would be possible. You can
Pascal,
and then probably need to operate HTML.
Yeah.
So what I would do
I'm
is
afraid
if
you
you
don't
put
have
that
you can add it. You can add it. You go back to the menu and
so you
add
can
marks.
this is will operate if you put that point what you're doing properly. So I would just use point X and point Y.
Which one did I do?
Point X
Oh, okay. You equals
So yeah, C++. So now this is, I'm so impressed.
Yeah.
This is really, really, really good. Is the source code on GitHub?
Yes.
Okay,
Can you please
Yeah, I said-
close,
I said-
exit properly?
oh, I'm sorry. That's bravo. That is really, really, really good. Can you post the link on the Slack chat?
It's there, but no one knows. But I'll post it.
Oh, yeah. That's 10 out of 10.
I was most impressed by when I got the list of all the students. I was expecting it to just go this sort of, it actually stops and goes like, hit a button to continue rendering the rest of it. Like, oh, it's passionate.
Because we are 108 in Slack. So we are.
Yeah, of course. Yeah, I was just impressed by that. UI aspects. I can accept whatever it is.
Well, I'm afraid, ladies and gents, the bar's been raised. The level of expectation is just.
Well, you know, it's not like, you know, middle school or something. We don't have teachers' pets, right?
No one brings me an apple before class.
That can be arranged.
An apple.
Actually, we're trying to bring an apple, but not that kind of apple.
Yeah, I'm still trying.
You've got 3.
I see. Your first session, and you're trying to get the teacher's pet badge ready.
Avoid learning.
Sorry?
I'll avoid learning anything. I'll just give up. It doesn't work that way. I think you have to choose.
Come along with the official Apple suppliers.
Official apples.
But it might get expensive if you start asking for iPads.
Yeah. Oh. Well, just suggesting this is neat, actually.
Gonna have to call time on this before I eat my own body weight in pizza, by the way.
Okay, so
Machine ID setup. System new machine ID setup.
You want just like Sparrow?
Sparrow?
Yeah. How Sparrows? Sparrows, it's there. You know, people say, I it's like Sparrow. But Sparrow actually is saying body weight distribution.
Yeah, I will actually. If I don't, I've got to stop. Mind you, will soak up all the beer later.
And now I made these nice slides.
Oh, that was nice touch. Good, yeah. You're coming up to hard film now. You've done some tricks and trade.
Okay, so I'll give you till past. So you've got another 3 minutes or so.
You like it, huh?
No, it wasn't about the tool you used. We click on one part of the,
I don't think so.
I'm not saying you're there. I'm saying you're getting.
Okay, I made one step out of million.
The thing is, though, your slides. So, like, when I do my fancy slides, I'm just saying, you now have a setting. No.
I agree with Justin. That's
right.
yeah, they got background too, but the code of scheme using it's very dated. I know. You see, some people go paste, some people get, like, speaker, designer.
You want to be like
you not want
Some
to
people do, but it's not you or me.
You see, the front, that's the reason. The front end is done by one type of people, and back end is done by other. And you can't do the front end.
See, I've just gone for the classic black and white.
Yeah, that's smart.
still
Oh, you C++ London, I used got flashy JavaScript revealed.js.
And that looks amazing.
That's quite cool. I've been considering that.
Yeah, it is cool, but it's very limited as to how much you can fit on a particular slide.
It's got a lot.
That's not bad.
Yeah, for some reason, I had an Office for Mac installation on the old one, and then when whatever the transfer process is called, anyway, the Office for Mac license didn't transfer across, so I can't run it. I can't run PowerPoint anymore.
I'll stop. Who wants another start?
I think I can probably manage for now.
When you
No, this is something that everyone just procrastinate, especially when I'm more. No, usually it does. Okay. So, no, these parts were in the so what I've done,
No, that's a different.
Are we trying to do something?
okay.
So what?
The actual bar on the left. Make it bigger.
Bar.
this thing,
So should we understand it?
and I'm
I mean the sidebar.
Yes.
No.
Okay,
Out to the text, which is in your favourite text.
let's move on because we've still got a few things to do. In fact, quite a bit to do. So we won't cover it all today, but never mind. The solutions to this little exercise are available there. So who managed to get the constructors working? Hands up. I'll walk past at least more than one of you. So no? Well. Oh, you're still spam GitHub spam, but okay. Well, maybe in that case, I won't show you the solutions, and you can just carry on with that on Thursday for those who didn't manage it. So, explicit constructors. So I'll tell you what, I will not talk about explicit constructors now.
So we did then talk about an explicit default constructor.
Yes. However, we are a little bit pushed for time and member initializers are more important. Yeah.
I actually got it to work.
Oh, awesome. So let's talk about member initializers instead. Member initializers are more important than explicit constructors. I can drop explicit constructors in there somewhere next week. So, yet again, reiterate, job of a constructor is to make the object ready for use, including setting initial values of any member variables. And one possible way we can do this is to set the value that we want to use in the body of the constructor. So this is probably what most of you did on the exercise just now. We had struct example, and then you can see our struct example has a member of type int, and then inside the body of the constructor we set I to 42. So most of you probably did something like that, just in that exercise. But C++ is very particular about the order in which it constructs things. It's very particular about the order in which it destructs things as well. But it's very particular about the order in which it constructs things. When it's constructing an object, first of all, it constructs all your base classes. Well, we'll worry about that later. But then it constructs all of your member variables. And it constructs them in the order that they are declared in the struct. And only after it has constructed all of your member variables does it then execute the body of your constructor. So all of our member variables have been constructed, that is, for class types have had their constructors called, their constructors are finished, by the time we enter the body of our constructor. Stop sniggering, Din. And the reason for this is it prevents member variables from being in an unconstructed state. So if we try to read the value of one of our member variables inside a constructor and use that perhaps to assign it to another member variable, this prevents you from getting into trouble with having some of your members constructed, some of them not constructed. It would be a bit of a mess. So it has this rule that says by the time control has reached the body of the constructor, all of our members are constructed. So it means that when we do something that we saw in the last slide, we just had I equals whatever I said it was, 42. That's an assignment. It's not construction. We've already constructed the int, or perhaps a string would have been a better example because a string has a constructor. We've already constructed it. And then what we're doing afterwards is assignment. So all our member variables and our base classes are fully constructed before we reach the constructor body. It's really important to know that. And usually this is done by the member's default constructor. That's one of the reasons it's called a default constructor. So if we then go in, if we do default construction followed by assignment, that's doing more work than we need to do. Constructing then assigning is twice as much work as just doing construction. And what's even worse is what if we have a type with no default constructor? Like this guy here has no default constructor. So if we try to use this pattern of doing the work in the body of the constructor, it's just not going to work because it's first going to try and default construct our member so that we can assign to it later. But if we can't, if we've got no default constructor, well, it's just not going to work. We're going to get an error.
Or it's cons.
So here I have a struct called no default constructor, just abbreviating it a little bit. And this has a constructor that takes an int and a float. and also a member variable called getInt that'll turn out to be useful in a minute, or instructive. So now we have struct example, and it contains a member variable named n of type no default constructor. Contains another member variable of type I. And we've said this type has a default constructor that we're going to write out of line. So now we have a bit of a problem. Because by the time we reach here, our member variable n must be initialized. And what it's going to try and do, because this is a class type and we haven't given a member initializer there, it's going to try and call a default constructor. It's going to try and call a constructor with no arguments. Well, this doesn't have any matching constructor that takes no arguments. It only has one, and that one takes 2 arguments. So we're going to get a compile error before we ever get to the body of the function here. Don't worry about the getInt bit. We'll come to that in a minute. So this is problematic. We need a way to say, I want you to call this constructor for me, please, for my member variables. Right. We need a way to select which constructor you use for your member variables. And we have a way to do that. It's called a member initializer list, because it's a list of initializers for our members. Finally, something that's named in C++ that makes sense. So the member initializer list is part of the constructor definition, not the declaration, the definition. And it appears before the body of the constructor, so after the parameters and before the body of the constructor, and it tells the compiler how we want to initialize all of our members, which constructors we want to call, what initial values we want to give them. So this time, rather than default constructing all of the members, it will use the values from the member initializer list. But again, and as always, by the time we actually reach the body of the constructor, that is the bit between the curly braces, all of the members are always fully constructed. That's a cast iron rule. So let's have a look what this looks like. Again, we've got no default constructor, no change to any of this bit. So this is just the declaration of the constructor, default constructor in this case. This is the definition. So you've already seen this earlier today. But now we do something special. We write a colon. So usually we put an opening curly brace there, but constructors have this special syntax called a member initializer list. And we introduce that with a colon, and then we write the name of the member, and then the constructor we want to call. So in this case, I want to call the constructor, so n is of type no default constructor. I want to call the constructor that takes an int and a float, which is the only choice I've got, actually. So this is saying, instead of default constructing n, I want you to call this particular constructor. And I also want you to initialize I, this is this int member, with the result of the getInt member function of n. So this is doing exactly what we tried to do in the previous example, except instead of doing it in the constructor body, it's doing it in the initializer list. And this works, I might go into this in a little more detail in a second. This works because members of a structure are always constructed in the order in which they appear in the definition. So we know that by the time we get to I, N will already have been constructed, so we can happily call this getInt member function. And this thing of doing all the work in the initializer list and then having an empty constructor body is unbelievably common. In fact, I would say 90% of the constructors I would write actually just don't have any body to them at all. They're just an empty pair of braces. You still have to include the empty braces, by the way. You can't omit them. You have to put them in there. But most of the time, you'll find that you can do a lot of the work you want to do in your constructor in the initializer list.
Do you think about, I'm just looking at the colon, can you think about that as inheriting the N?
Not really, no.
You know, the syntax looks, I'm trying to...
Yes, and actually,
It doesn't work like that.
well, actually, it's a separator, really. But if you do want to think of it that way, this is you use the same syntax. You initialize your base classes in the member initializer list as well. So you typically write your base class constructor, then your member constructors.
I'm going to bring it up because I remember last time you mentioned it. What was the reason behind using parentheses over curly braces in the initializer list?
Here, absolutely nothing.
Yeah, it's on there, but you gave it a motivation. I could have sworn you gave a motivation for avoiding curly braces in the initializer list.
I probably did, because I used to be quite smart, and now I'm just...
In this case, you could replace the colon end bit with parentheses. You could replace those with braces, no problem.
I could replace them with, yes, that's very well observed. I could replace them with braces with no problem there, and here as well. I could use curly braces instead of the round brackets, because this is a non-aggregate type that doesn't have one of these stupid list constructors. Yeah?
Please forgive me, I was looking on my phone at something. I kind of missed the point of why we have a member initializer.
Okay, it's
What problem does it solve?
it solves two problems. Firstly, this thing, the members it has to be fully constructed by the time we get into the constructor body. Right? So there are two ways of doing it. Either you sort of default construct it and then assign it an initial value, but that's doing more work than we need to, because it's more efficient just to give it the initial value in its constructor. So, and the other problem is if it doesn't have a default constructor as our no default constructor class, then we need to say, we need to specify which constructor we should call.
Also, if it's const and it either doesn't have if it doesn't have a default constructor, you can't do it anyway. Say you have a const string, you don't want the default constructor, you want to actually put something in it. Because having an empty string is generally useless. So if you have a constant string in your class, you have to put whatever string you want in it in the initializer list. Once you go into those curly braces in the body, everything's ready to use. And since it's const, that's it. You can't change it.
So this bit here, between the declaration signature part and the opening curly brace, this is the member initializer list. We introduce it with a colon, and then you don't have to write it on 2 lines. I've just done that for neatness. But we list our members that we want to initialize separated by commas. Now this is really important, and a lot of people get it wrong, but it's really important. It's so important I put it in red. Member variables are always constructed in the order that they appear in your struct definition. Always, always, always. They are not initialized in the order that you write them in the member init list, member initializer list. The order that you write them in the member initializer list doesn't matter at all. They will be initialized in the order you write them in the struct definition. So, for safety, write the elements in your member initializer list in the same order as they appear in your struct definition.
And if you use a recent compiler, it will warn you they are out of order.
Most compilers today will warn you if you do not.
Don't even need to read the slides, guys.
Right, so, why is this a problem? Well, if we... Oops, that was not what I wanted to do, sorry.
Sorry, can you just put back to the previous slide, please?
The previous slide. This one, yeah. We'll get there in the end.
So just here, just
yeah.
With regard to order and initialization list.
Yes.
Initialization list. You've got the n being constructed.
Yep.
In the first in the initialization list, really to match what's in the struct example.
Yes.
But then of course you're calling get int.
Yes.
Which obviously the prerequisite for that is n has been constructed.
Yes.
So just to be explicit, you could put n get in first and then n one to all over the crazy.
You could. You absolutely can, and it will still work. This is guaranteed to work because n is guaranteed to be constructed first. So you're absolutely right. If in the initializer list I flip those two round, it wouldn't matter because always they get constructed in this order, not in this order.
If you reorder them in the
But
definition.
if you were to flip those round, it's going to be really weird because it looks weird. It reads weird because we're used to seeing instructions happen in the order that we write them.
You should be consistent.
Yeah.
But also, more importantly, if you did flip them in the struct example and definition, it would crash horribly.
Yeah. So if we flip these over, so this is why it's dangerous. So if we flip these over, so if we had int I and then no default constructor n, and then somebody later in the initialized list wrote it this way, thinking it was going to work, that would be a problem. Because actually, I would be initialized first. It would try and call this getInt member function on an unconstructed thing, and crashing would probably result.
So that's why it's probably really good that the compiler warns you that they're out of order.
It's really, really good, yes.
Because otherwise that can waste a lot of time.
Yes.
It's good that the compiler warns you. It's really good if you set warnings to be errors.
In the previous example, when we created that my type thing with the string or the int or the default thing,
yeah.
We had first this free initializer, one of which was the initializer with the string that gave the value as to the variable str equals string or whatever it was.
Oh, yeah.
And then the variable was at the end. Was okay?
Yeah.
Or was just
Yes. So the order in which you write your member variables, so that's these, and your member functions, that doesn't matter.
okay.
You can typically, what we normally do when people are writing classes, they'll put the member functions first and the member variables at the bottom. And that's usually because we haven't really got there yet. That's what I'm planning to talk about next week. Is you usually make your member variables private, and so the member variables are public. That's what somebody else who's looking at your class definition cares about. So you put those up front. But technically C++ doesn't care, and you can interleave them as you wanted to. So if we wanted to, we could write no default constructor, member, the example, declaration, and then int I down there. And that would, C++ doesn't care. So finally, we talked about the member initializer list. We can have a default member initializer. So a default member initializer is attached. Oh, already used that. Is attached to the declaration of our member. So here, I've got my struct point, which is an aggregate again. But I've given X a default initializer of 42 and Y a default initializer of 99. So these things, this bit here is called a default member initializer. So this is the member, and this is the default value if we don't override it in a constructor initializer list. So if I now give this a point to a constructor, let's actually just give it 1.
Could you override that and initialize it?
They absolutely can, yes. So here, I've done a few scribbles, apologies. So now I've given struct point a constructor that takes one argument that I've named I, and in my member initializer list, I initialize X, my member X, with the value I. So if I call point brackets 3, X is going to be initialized to 3, and I haven't mentioned Y in the member initializer list. So if I haven't mentioned it, it's going to look for a default initializer. In this case, the default initializer is 99. And if it hasn't got a default initializer either, then it gets default constructed, which means a default constructor if the class has one. Otherwise, if it's a built-in type, some random unknowable value.
So if I call with a pointer with a value, it will get the value. Otherwise, we get the default value.
Well, point now is not an aggregate because it's got a constructor. And it's got one constructor that takes one value. So as I've written it, there's no way of setting Y in the constructor.
No, if I give a value, that will be the value for X.
Yes.
If I don't give any value, we'll get this X equals 42.
No, there is no. You cannot call this. This has no default constructor at the moment because we only get a default constructor if we don't write any constructor systems. So in this case, we have defined this constructor here, and we said you must supply a value when you're trying to construct a point.
What happens in my main I call pointer to curly brackets?
It would say cannot find a matching constructor because there is no constructor for point now that takes no arguments.
Is that just not an aggregate now?
It's not an aggregate now because we've written our own constructor for it.
Oh, that's what's changed.
Yes. So when I did it before, when I didn't have this, it was an aggregate. Now it's not an aggregate. This thing about aggregate types, when I've done this before, I've sort of skipped that because it's a bit like, well, it's not a trap, it's just initialization in C++ is weird. And I've skipped talking about aggregates because I initially thought, oh, it's just really confusing and I want to try and keep it simple.
Is aggregate types are like enums in Java?
I don't know enough about Java to say.
No, enums in Java are like enums in C++.
Oh, okay.
So if you call the default, if you now have put a default.
If I now gave it a default constructor as well, equals default.
Yeah, X would be 42 and Y would be 99.
Absolutely, yes.
An aggregate is like a pogo. Aggregates and pogos are basically
But yeah, if you just, like Barbara said, if you just called point, it would just crap out.
As written, yes. Yes.
With the default, if you with the default, if you just call point
Point P.
Point P, and then you had default constructor in there.
And you had a default constructor, it would call the default constructor. Yes, absolutely. No. This is fine. So, actually, no. I'll when I put the slides up, I'll put something in there because I actually wrote something called the Constructor Playground for people to play with all these things. So it's on the GitHub, but I'll put a link to it when I put the slides up. So, if we mention a member variable in our member init list, that is the colon thing in the constructor, that's how we will initialize it. If we don't mention the member in the member init list, it'll use its default initializer. And if it doesn't have a default initializer either, it will be default constructed, and for built-in types, that's potentially dangerous because it just leaves it full of random junk. So for this reason, we say always ensure that your members are correctly constructed. So basically, it's always worth putting an explicit member initializer in there. Because it's not going to cost you anything, but it could potentially save you from accidentally reading junk.
So, just interesting, how would you do point one? Just point one?
So at the moment, there is no way of setting y in the constructor.
If you had point int j and then colon y,
You can't overload. No, at the moment, there's no way of setting y in the constructor.
You can set it on.
Yeah, but y is a public member at the moment, so you could just do p.y equals whatever. That's not a very good example. It's just off the top of my head. So let's go back to this example. We have our struct with no default constructor again. We have this getInt. So now I've said, I don't think this is going to work. Sorry. This definitely isn't going to work. I apologise, I've made a mistake here. Let's try again. So now we have struct example, and it's got a member type no default constructor named n, and now we're initializing it. We're giving it a default initializer that calls the constructor that takes an int and a float. And my rapid edit was because I put round brackets in there before, which would have declared a member function. Because this is an int, we can use the equal syntax, and we can give it a default member initializer that calls n.getInt. And again, always the member variables are initialized in the order that they're written, so this is always safe. N will always be initialized before we reach this here. But if we flip those round, that would be a mistake. So now I'll give an example. Two constructors, a default constructor and a constructor taking an int and a float. So I'll write this constructor first. We can say, example, constructor taking an int and a float. And in my member initializer list, I'm going to pass I and f to n's constructor, so this constructor here. So again, this is a common thing to do, to use any constructor arguments that you've received to pass them on to your children, if you like, your members. So this is going to initialize n with these values. And that's all I'm going to do. Because this is going to initialize n, and then it's going to initialize I. Well, I haven't mentioned I in the member init list, so it's going to use the default member initializer, which is going to call getInt on n. So that's going to work just fine. And now for the default constructor, well, now I can just have an explicitly defaulted default constructor. And what this is going to do is it's going to call n with 1 and 2, construct n, sorry, with 1 and 2, call the n constructor, and it's going to initialize I with the result of n.getInt. So this thing about member init lists is kind of weird to get started with if you're used to something like Java that doesn't have this. You just set the values in the constructor. But once you get used to it, you find most of the time you find yourself, as I say, doing most of the work in the member init list, and you very often will just have a constructor with an empty body like that. And that, with 3 minutes over, so sorry. But that's it. That's all I have for today. So, as always, I'll put the slides online, and I'll give you a bit of homework to do, and I'll put a link to the Constructor Playground as well, so you can have some fun trying out various things. Next week, we're going to talk about public and private member access. We're going to, if we have time, talk briefly about enumerations. And then that's going to be it for this module. So that'll be week 5, the 5th and final week of custom types. And as is customary, as people who've done this before will know, we like to just give you a friendly questionnaire. It's definitely not a test. A friendly questionnaire to finish the quiz.
Which has correct and wrong answers.
So that we can know, me in particular, I can know how well people have got on. Have I gone too fast? Should I go into more detail about this? It's useful feedback for me, but it's also useful feedback for you. You can go, oh yeah, I've mastered that, I'm awesome. Or you can go, oh, okay, maybe I need to go back and read a bit more. So that's it. Thank you very much for coming, and see you next week. Thank you.
Anybody want to take any of your home?